In Glasgow, Scotland, towering flames gut a national treasure.
Fire engines arrived, flames started leaping out the roof. The biggest fire I've ever seen in my life.
Catastrophe in New Zealand as flooding devastates a farming community.
I knew damn well that it was going to burst, it was going to go. And it just kept coming and coming.
The water velocity around the town was just immense.
Tragedy in Texas after a fatal leak at a chemical plant.
It was unexpected, and that caught everyone off guard.
And in Nebraska, disaster strikes a titanic TV tower.
All the steel beams are just twisted, mangled.
With big builds, even the smallest fail can trigger a huge disaster. From miscalculations to misunderstandings, or just plain bad luck. These catastrophes are every engineer's worst nightmare. With everything they create, engineers build to stand the test of time. But sometimes catastrophes lie hidden beneath the surface for years before they strike. Like this disaster in Scotland, where a world-renowned art school went up in flames.
It was like a scene from Dante's Inferno. I mean, it really was devastating.
Ancient engineering that sparked a present-day disaster.
Blazing through the building. This looked like something of a completely different scale, and it was.
As not one but two fires raged through one of Scotland's most historic buildings.
More than 100 years of history have been destroyed.
Glasgow, Scotland's largest city, thrived thanks to the River Clyde and its docks, and has gained a reputation as a strong industrial city.
Glasgow has always had a tough and steely image, but behind its blue-collar roots lies a city as vibrant and rich in culture as anywhere else in the UK.
In a city where grit and glamour go hand in hand, some of Glasgow's structures like to stand out from the crowd. None more so than this building from the Glasgow School of Art that opened in 1909.
This was originally conceived as a training institution for designers who would then work in the city's thriving industries. But today, it's recognised as one of the top 10 art schools in the world.
This iconic building was designed by one of the city's favourite and most famous architects, Charles Rennie Mackintosh. Johnny Rogers is a professor at the school.
Mackintosh was probably the greatest architect who ever lived in Scotland. So it's always been a very important art school, and many great artists, architects, and many great designers have studied at this school too.
The iconic structure is mostly sandstone and timber.
He designed everything in that building, not just the exterior, the interior, every single point of it.
And this one room is widely considered to be the architect's finest work.
The Jewel in the Crown, the Mackintosh Library, which has the most delicate and wonderful space in Western architecture. Such a spectacular, beautiful, tender, quiet place.
For architect Gordon Gibb, as both a student and lecturer here, it was nothing short of inspirational.
It was not only a thrill to be in this building, but also it was in itself an education. There were so many things about this building that taught you how to be an architect. I found the building awe-inspiring every time I was in it.
But this building that motivated generations was about to be brought down by the very things it inspired: art and architecture. Friday, May the 23rd, 2014. At 12:27 p.m, the Scottish Fire and Rescue Service responded to an emergency call. Glasgow's most historic building was on fire. Journalist Norrie Wilson witnessed the blaze.
There was smoke billowing from the library end of the building, and as more fire engines arrived, flames started leaping out the roof. All of a sudden, you realised, hang on, this is pretty serious.
The art school was evacuated as fire crews battled to save the building. Word spread quickly, and Gordon Gibb rushed to the scene.
The reality struck home when you saw large parts of the roof on the west part of the building missing and smoke still rising from it.
Students watched helplessly as their work was reduced to ashes.
It wasn't just that the Glasgow School of Art was on fire. There was an entire year's worth of graduates' work was going up in smoke, things they'd been working on for months, if not years.
It took more than 7 hours, but finally, the fire was under control. While most of the building remained intact, one area had been completely gutted.
The real loss was the Macintosh Library.
An unimaginable loss.
Not just one of the most remarkable spaces in Scotland, it had to be one of the most remarkable spaces in Europe.
Thankfully, no one was hurt, but over 100 years of history had gone up in flames.
The general feeling was one of horror and one of shock. The jewel in the crown had been burnt, had gone.
How did this happen? How could this have happened?
In the immediate aftermath, the full scale of the devastation soon became clear.
What was lost was the library's contents. Thousands of original books, going right away back to the Italian Renaissance, which was just lost completely. Books that if you wanted to buy again, if you could buy again, would cost you tens, if not hundreds of thousands of pounds.
The Fire and Rescue Service immediately launched an investigation. They pinpointed the source of the blaze to a room in the basement, where a student had been working on an art project.
One poor student is putting the final touches to his degree show, and he used a can of expanding foam too close to a hot projector, which ignited. And before they knew it, that small fire couldn't be controlled.
The can contained highly flammable polyurethane foam. Kristen Salzer-Frost is a lecturer and fire safety engineer.
Polyurethane foam burns very, very quickly with lots of thick smoke, and that fire will have spread very quickly.
Although the students' project was the trigger, the speed at which the fire spread was terrifying. It came down to the building's historic architecture.
They've used what they call lath and plaster, was a very common technique of the era, and that can deteriorate very quickly in a fire situation.
Lath and plaster uses strips of wood nailed horizontally to a timber frame, then coated in plaster to create a surface. The trouble is, it can provide a channel for the rapid spread of fire, so it was phased out in the UK almost 100 years ago.
This outdated construction technique wasn't the only problem. The structure's original timber ventilation system had served as a conduit for the fire.
Macintosh had designed a state-of-the-art heating system to spread hot air throughout the building.
Those ducts were timber lined and were combustible themselves and spread to other rooms in the building very quickly and without being seen.
The timber ducts had been abandoned in the 1920s, and they acted almost like flamethrowers. So the fire started in the basement but spread up through those ducts to the Macintosh Library.
The result was more than 100 years of history reduced to ashes. While many artifacts were lost in the blaze, in the years following the fire, the historic library would be reconstructed piece by piece, restoring it to its former glory.
Everything was to be meticulously recreated, even down to the rare tulip wood, which had to be imported from a disused sawmill in Massachusetts.
The most skilled craftsmen from across Britain to start recreating it, all done exactly as Macintosh had specified.
For 4 years, the restoration team worked to bring the library back to life. But almost unbelievably, disaster was about to strike for a second time. The historic School of Art was once again ablaze.
They say that lightning never strikes the same place twice, but I'm not sure the people of Glasgow would agree.
The biggest fire I've ever seen in my life. It was like seen from Dante's Inferno. The flames must have been going at least 400 or 500 feet in the air.
Blazing through the building. This looked like something of a completely different scale, and it was.
More than 100 firefighters battled the blaze, but as the inferno spread, the situation became increasingly hopeless.
The fire had taken hold, and it was soon burning through the whole building.
While no one was hurt, this time the damage spread well beyond the library.
We just stared in shock and awe because the building had gone.
People were just totally devastated by it. It was a total disaster. How does an art school burn down twice in 4 years? It just seemed unbelievable, impossible, devastating.
The authorities launched another far-reaching investigation. But the damage was so great that the source of the second fire remains a mystery.
Because of the complete destruction that was wreaked in the building, nothing is left. They can't determine what was the ultimate cause of the fire. They don't know. It's impossible to tell.
With estimated rebuilding costs that could exceed £100 million, the structure could take decades to restore. But many hope that eventually this historic building will rise once again from the ashes.
It was such a great achievement by an architect. I think it can be rebuilt, therefore I think it should be rebuilt. I think we owe it to history to rebuild that building.
Engineering always has to stand up to the forces of nature. Any points of weakness can lead to disaster. Like this failure in New Zealand, a sudden collapse that caused a major catastrophe.
So quick, it just happened. There was just so much water.
A mighty deluge that laid waste to a small community.
I knew damn well that it was going to burst, it was going to go.
This huge flood triggered a dramatic rescue.
We launched our boat and started to pick up people.
This disaster was a brutal reminder of the power of Mother Nature.
On the coast of New Zealand's North Island lies an area known as the Bay of Plenty.
The Bay of Plenty got its name from the English explorer James Cook because of the abundance of food he discovered when he landed here in the late 1700s.
The region has 160 kilometers of Pacific coastline, inland mountain ranges, and even active volcanoes. A perfect home for locals like Brandon Crowley.
I've lived in the area my whole life. Quite picturesque. It does bring you a lot of stress relief. It is very rural based, a lot of dairy farms, a lot of kiwi fruit and horticulture, so it's quite diverse. It's a hub of rural community.
This fertile land is known as the avocado and kiwi capital of New Zealand. Kiwi fruit alone accounts for around $2.5 billion of the region's annual economy, producing more than 80% of the country's entire crop.
Gary Bryson has been farming near the small town of Edgecombe for over 30 years.
It's a thriving little town. We manufacture stock feed and export maize overseas, which is quite a thriving little business too.
Luckily for farmers, the Bay of Plenty also has an abundance of fresh water, with 10 rivers feeding the region. The largest of which is the Rangitaiki, which flows right through Edgecombe.
This is one of the main rivers that runs right the way from central North Island and heads out to the ocean here in the Bay of Plenty.
Over the years, the course of the Rangitaiki River has been altered to bring its waters to greater areas of farmland. But with the water came the risk of flooding.
The solution they employed, popular around the world, is a system of man-made levees, known in New Zealand as stop banks.
Stop banks are essentially long earth embankments designed to keep the rivers and the streams under control. Here, grass grows over them, and they essentially blend in with the landscape.
The construction of the stop banks is generally laid in layers and compacted. I've built a few stop banks myself. They are critical engineering, the integral part of keeping the community outside of the river safe.
In Edgecombe, the main road runs just beside the river, so in the 1970s the stop bank here was modified to ensure its integrity. Like many stop banks, the main embankment was built from compacted clay, sand, silt and rock. Then a timber frame called a crib wall was built to hold the roadside firm, while a 1.5 metre high concrete barrier ran along the top as an extra measure to contain a fast-flowing river. First constructed in 1973, the stop bank battled to hold floodwaters at bay for more than 40 years. But Mother Nature was about to deal it a killer blow. Early April 2017, Cyclone Debbie moved in from the Pacific Ocean, settling over the Bay of Plenty and Edgecombe.
The river was already high due to heavy rains in March, but over the next 2 days, the cyclone dumped around 35 centimeters of water here. That's nearly 3 times the monthly average for this area.
By Thursday, April 6th, the deluge had stopped. Local farmer Gary Bryson was walking through town.
About 7 o'clock or so in the morning, I saw the water coming underneath the concrete wall, just oozing out.
With water pouring onto the road, Gary took photos to show local government officials. Another Edgecombe resident, Graham Burke, was driving through town.
I stopped and I got out of my van, and as I was getting closer, I can actually see the stop bank bulging.
I knew damn well that it was going to burst, it was going to go.
At around 8:30 a.m., Gary was proven right. The stop bank and the flood wall failed catastrophically.
It just fell to bits, and there was a torrent of water.
As the overflowing river burst its banks, people were left with just minutes to get out.
You had no time. You had to the water didn't wait for anybody.
With no barrier, the runaway river was relentless.
And it just kept coming and coming, just miles away, just colossal.
There was just so much water going into the town. It got deep real quick.
The streets turned into rivers, and a full-scale evacuation was ordered.
Hello, get out, come on! Yep,
Those with boats like Brandon Crowley raced to help people where main streets had once been.
We drove down the road, drove over the bridge, not under it, looking up driveways, and it looks like a rapid. The water velocity around the town was just immense.
The fast response of Brandon and others in the community ensured that everyone who was stranded made it to safety.
As much as we were in shock, we just did our best to do what we could to help out.
Just the day before, school principals had made a decision that further helped prevent the loss of life.
Because there'd been so much rain, they closed the school. Now, at the time that wall went, there's usually about 50 school kids walking along on their way to school. There would have been a lot of children drowned.
Thankfully, the residents of Edgecombe all escaped unharmed, but the flood was devastating to their livelihoods.
We lost all our crop, approximately about $750,000. We just lost a lot.
The flood hadn't just laid waste to crops and local businesses. More than 250 homes were left uninhabitable, with 15 of them damaged beyond repair. Authorities declared a state of emergency, and the entire town remained evacuated while the damage was assessed. Why had a protection system designed to keep the community safe failed so catastrophically? The obvious suspect was the recent storm, Cyclone Debbie.
The storm dumped so much water in the river so quickly that the floodwaters were around 6 meters higher than normal, the highest level ever recorded.
So the average flow of this river generally is around 30 to 40 cubic meters a second. During the flood, it was just under 1,000, literally 200 times the flow that you see coming down the river today.
When water pours over a dam or flood defense system, it can cause catastrophic erosion. And yet here, the river never actually flowed over the wall.
Eyewitnesses said that instead, they saw water coming through the stock bank, much lower down, then pouring onto the road beside it.
I said, this wall is going to collapse, it's unstable. And I said, look, there's photos, and that's when they said, whoa.
The key question was, why had water poured through the stop bank? Investigators turned to the flood wall.
In 1987, a major earthquake hit the North Island with its epicenter close to Edgecombe. The stop bank was badly damaged and the flood wall suffered foundation failure, so the wall had to be completely rebuilt.
The stop bank was repaired and a new flood wall built on top. But there's no record of whether the wall's failed foundations were fixed. Excessive water from Cyclone Debbie would have exploited any weakness between the flood wall and the embankment, eroding new gaps in the compromised foundation. Increasing pressure from the flood forced water through the stop bank and out of the crib wall. The investigation found that this led to progressive failure, first of the crib wall, quickly followed by the flood wall itself.
Once it started eating away inside the embankment, the erosion got worse and worse, adding water from a once-in-a-500-year flood, and this was only ever likely to go one way.
Following the disaster, the 12 houses directly opposite the breach were rendered uninhabitable and demolished.
Quite a few people left the town, like we did. There's still people that psychologically you can see that the flood has affected them.
You're just on the merry-go-round and you've got to keep going. But then later on, it gets you. You start thinking. It'll take lifetimes to get over.
A new and improved and larger stop bank has been built, while a stronger flood wall will complete the last part of the process.
With the stop bank failing and the houses on the adjacent side of that basically being wiped out, that was the option to push the road further back and rebuild the stop bank to a much higher standard.
At the core of the stop bank, engineers planned to fit steel sheet piling encased in concrete, effectively creating an impenetrable barrier that should prevent water from ever flooding through again.
In big engineering, robust design and construction are just the beginning. Sometimes problems lie in day-to-day operations. Like this story in Texas. A catastrophe that struck a chemical processing plant.
The event is really a series of dominoes that fell one after the other.
A sequence of misunderstandings that produced fatal results.
These employees were rushing to help their coworkers.
This disaster was a powerful reminder for engineers that any misunderstanding can end in tragedy.
Houston, Texas, has long been the epicenter of America's oil industry. Christopher Cook is an investigative journalist.
Oil is a primary product in Texas, and all sorts of oil byproducts and petroleum byproducts produced in Texas.
The modern world depends on petrochemicals, and they're not just used for fuel. Crude oil and gas can be refined into the ingredients for all kinds of everyday products.
They're found in everything from the plastics we rely on to sunscreen and laundry detergents.
Today, facilities that produce these raw ingredients line the shipping channel that runs from Houston down through Galveston Bay, including here at La Porte.
La Porte is an intensely industrial zone in East Texas. There's production of all sorts of petroleum products, insecticides, and other chemicals in that area.
These products might seem commonplace, but producing them is a dangerous business. Michael Wong is a professor of chemical engineering.
So many things that we take for granted in our daily lives that we really don't appreciate all the hazards that come along with manufacturing these chemicals and products at a large scale.
We've seen over time in the history of chemical production, industrial production, that these chemicals are highly toxic. These are products that really need intense scrutiny and care in how they're handled, if they're to be used at all.
And in 2014, this area bore witness to an event that tragically drove home those dangers. Wednesday, November the 12th, a cold autumn day in La Porte. At this chemical facility, personnel were planning to restart their insecticide production reactor. Chemical engineer Michael Wong explains.
The way they make pesticides is the way they make chemicals at a large scale, generally using chemical precursors that they combine into a reactor, sometimes heated, sometimes pressurized, and then what comes out of it would be the product.
Here, the insecticide contained a cocktail of chemicals, including the highly toxic ingredient methyl mercaptan.
Methyl mercaptan is a dangerous compound. They use this molecule to actually tell folks that you have a natural gas leak. It's a very distinctive smell. Some would call the methyl mercaptan smell to be the smell of rotten cabbage, rotten egg.
Our noses can detect methyl mercaptan at very low concentrations, which makes it the perfect alarm signal. The problem is, at higher concentrations, this potentially life-saving compound can be deadly.
Methyl mercaptan is highly dangerous because it is a poison. If the body comes in contact with either through the liquid phase or through the gas phase, it gets into your body, and then the body does not know how to react with it other than to shut down.
Methyl mercaptan, like all insecticides and other toxic substances, to the extent that we use them at all, really has to be treated with care and respect.
A temporary closure had caused the insecticide system to be shut down for 2 days and nights. In the cold weather, the chemicals had formed a blockage in the pipes, preventing the unit from restarting. Clearing the complicated network was no easy task.
Workers were dealing with chemicals essentially hidden inside the pipes. So although they knew what they were trying to do, they couldn't see what was actually happening inside.
All told, they spent more than 2 days warming the chemicals while manipulating the pumps and valves before they believed everything was flowing properly again.
At 3 a.m. on Saturday, before the unit was restarted, the control room operator saw a pressure alert for a waste gas venting system. Prior experience suggested a buildup of water vapor was triggering the alarm, so 2 workers went to release the pressure at a valve in the main building.
By doing so, they had expected water and safe compounds to come out, but instead they found methyl mercaptan.
Roughly 24,000 pounds of methyl mercaptan were released into the facility.
One of the workers called for help, but it was too late.
The methyl mercaptan liquid became methyl mercaptan vapor, and the vapor suffocated the operators. It was unexpected, and that caught everyone off guard.
Tragically, 2 more colleagues were coming to rescue the stricken operators, but they also lost their lives.
these employees were rushing to help their coworkers and to try to minimize harm. That was their aim or hope, but they died in this accident.
The gas continued to leak for more than an hour until emergency crews with full protective equipment arrived to shut down the valves. In the aftermath of the disaster, the Chemical Safety Board launched an investigation.
There were many questions about what was the source and cause of the accident. The fact that several people died at a chemical plant is always and very upsetting.
The investigation found that there had been an unexpected chain of events that all started with efforts to clear a slurry blockage from the system 5 days earlier by flushing the pipes with hot water.
The event is really a series of dominoes that fell one after the other. And the first domino really started with the reactor being cleaned out and having to restart. And so they cleaned that out with water, pushing out the methyl mercaptan and other things that plugged up the distribution pipeline. That would not have been a problem, except they forgot to turn off one of the valves.
Although the flushing cleared the slurry, a valve was unintentionally left open, allowing water to flow into feed lines that should only have held liquid methyl mercaptan.
Because of the cold weather, the water and methyl mercaptan formed an ice-like solid known as hydrate, which completely blocked the pipe.
In order to unblock this pipeline, they had to warm up the pipeline to melt, essentially, this hydrate.
But as the warming chemicals started moving, they caused a pressure buildup in the pipework.
From here on, what workers thought was happening in the pipes and what was actually happening were two very different things.
Now the toxic liquid flowed into a waste gas venting system where it was never meant to be.
The methyl mercaptan ended up in the vent pipeline, then accidentally flowed into the vent system.
This buildup triggered the alarm in the control room. Operators believed it to be water vapor, which the two workers went to release.
What the operators would do when they see a pressure increase in the valve line was that they would then release the valve here to release the pressure, to allow the pressure to drop to release the water that was causing the pressure increase. But instead of water, they were getting methyl mercaptan. And as soon as the methyl mercaptan came out, the methyl mercaptan liquid became methyl mercaptan vapor. And the vapor suffocated the operators. And no one knew about it until it was too late.
In the end, complex engineering design, misunderstandings and bad luck came together here with fatal results.
Following the investigation, the Chemical Safety Board, or CSB, published extensive guidance from process safety to emergency response.
The CSB recommended automatic alarms to alert personnel of hazardous situations, better training for workers who might be exposed to them, as well as a long list of other guidance, in the hope that a disaster like this can be avoided in the future.
We need to ensure that all the workers in these facilities get every last bit of training that they need and safety precaution and process safety that they need, and that there is respect for the intense toxicity and volatility of these materials.
Epic feats of engineering depend on numerous elements all working together. Miss just one and the consequences can be tragic. Like this disaster in Nebraska that destroyed a vast TV tower.
I saw a puff of smoke. That's when I saw it fall down. The young lady said her boyfriend was up on the tower and she said, "Please help me find him."
This immense steel tower crashed to the ground in seconds.
And revealed an engineering oversight that led to tragedy.
It just looked like a big pile of spaghetti. You know, all the steel beams were just twisted, mangled.
Hemmingford, in the panhandle of Nebraska, is a small town with a big heart. Farmer Don Jesperson is a lifelong resident.
Hemmingford is a small community of like 1,000 people. Kind of the joke is, everybody knows your business. That's the bad thing, but the good thing is everybody knows your business.
From the 1960s, the close-knit small town was home to something gigantic. A nearly 600-meter-tall TV transmission tower.
TV towers are some of the tallest structures in the world. It's all about transmitting the signal as far as possible, whether it's over city skylines or vast open countryside.
And locals were happy to have theirs here.
People in Hemmingford love their TV, especially back in the day. It was a big deal. When they built the tower, we went from 1 channel to 3 channels, so it's pretty awesome.
The TV tower is long gone, replaced by a comparatively tiny cell phone mast. Its predecessor would have towered over even the tallest buildings in Manhattan. Journalist Brian Kewen heard firsthand about the stunning views.
My father was there when the tower went up. You even got to go to the very top of it. And when you got to the top of that tower, you could actually see the curvature of the earth.
It was one of the taller structures in the United States. It was a landmark no matter where you were coming from.
Across the US, most TV masts rely on the same basic but strong steel lattice structure for their height, the truss. Civil engineer Daniel Linzell explains.
So the tower is a series of trusses arranged in a triangular pattern. Those trusses are constructed where you have a bunch of members that are loaded in tension or compression.
The triangle is the strongest shape in engineering, both strong and relatively lightweight, which makes them the perfect choice for tall structures like a TV tower.
And there's a series of what are known as guy wires that help stabilize the entire tower throughout its height. And that's how it's constructed, that's how it's designed.
These towers have to stand strong against anything Mother Nature can throw at them. But if just one part fails, the whole thing can come crashing down.
By the autumn of 2002, 4 decades after the tower was first built, the arrival of high-definition TV demanded an upgrade of the antennas.
The high-definition antennas that were being placed on the tower were heavier than the existing antennas, so parts of the tower needed to be strengthened, which meant replacing them with larger components.
Working at heights is always dangerous, but some of these operations would take place way higher than the top of the Empire State Building.
They needed to pay special attention to the sequence, and they also had to pay special attention to the connections between the existing members.
With a solid plan in place, confidence was high for what the upgraded transmission tower could bring to the region. But little did the construction crew know, it wouldn't last. September the 24th, high over the Nebraskan plains, 2 workers were busy reinforcing the TV tower. One man was 120 meters up, the other at 490 meters. Don Jesperson was working in his fields nearby.
I was kind of roughly up over the hilltop there in my combine, and I was heading this way towards the tower, and I just happened to glance up at the tower, and I knew something wasn't right. It was kind of doing a shaking thing pretty bad. It seemed like it went on for a long time.
As Don watched on in horror, the tower seemed to shake itself apart.
That's when I saw it fall down. I knew I had to get up there. I'd see what had happened. And I called my wife on the radio and told her to call the rescue squad to come out, and we needed some help.
Journalist Brian Kewen heard the news.
I couldn't believe it fell. When I headed out, when I got there, it was just a shock.
When Brian arrived on the scene, he found rescue crews assessing a tangled mess of steel.
A lot of the tower just fell straight down, and it just looked like a big pile of spaghetti. You know, all the steel beams were just twisted, mangled, right at the bottom of that.
There was just all kinds of metal and cable, and it was terrible.
Beside the wreckage, there was another witness to the collapse. The girlfriend of one of the crew members had come to watch him work.
The young lady said her boyfriend was up on the tower, and she said, please help me find him.
The rescue crews that came out, they were doing their job. The law enforcement was doing their job. They were taking care of that young woman. Everybody did what they had to do.
3 workers on the ground had been injured, but tragically, the 2 men who had been working on the tower died in the collapse.
When there is something that traumatic, people come together, and it affected the lives of the people that were here that day.
The tight-knit community of Hemmingford was left reeling.
Couldn't believe it happened. That tower had been a fixture in our community for ages. It was just part of our landscape. I was shocked to see it fall.
Within days, official investigators arrived to identify the cause of the tragedy. Evidence and eyewitness descriptions led them to believe the failure had started at the lower site on the tower, where a worker was replacing key members of the truss latticework. Civil engineer Daniel Linzell knows the case.
So section 47 was the lower section, about 400 some feet off the ground. And what was occurring was members were being replaced. So members were being unbolted from other members and then new members placed in.
With a truss, every member, whether horizontal, vertical, or diagonal, plays a key role. They can be safely removed for replacement, but only if something else temporarily does the job for them.
So what the contractor could have done is place a temporary cable structure, it's commonly referred to as a come-along, in the bolt holes directly adjacent to the steel members that were there.
These come-alongs are steel wires, ratcheted bar tight with a hand crank, effectively acting like a strut under tension until a solid replacement is fitted.
But after examining the bolt holes of section 47, it seems the come-alongs were not actually bolted into place.
If the bolts had been in place, the holes would have been damaged or stretched out of shape when the tower collapsed.
But these holes were still perfectly round, so investigators were sure there were no bolts in them at the time of the collapse.
With no come-alongs to hold the truss intact, the removal of critical diagonal members caused a fatal weakness.
So a mistake made was removal of important members, members that would provide stability and would brace other members in the tower without putting temporary members in.
Once that diagonal was removed, the legs in that section lost their capacity to support the load.
When one leg became unstable, then that leg buckled and the collapse initiated.
Just that little tiny mistake made that whole thing fall. Pretty shocking.
In the aftermath, it was concluded that the temporary supports would have averted disaster.
Come-alongs could have prevented the collapse. Analyses that were completed by the OSHA team after the unfortunate collapse indicated that providing just a minimal amount of bracing to that leg would have increased its buckling capacity appreciably.
Engineering on a massive scale is always dangerous, and this tragedy was a powerful reminder that every piece, no matter how small, can have a crucial role to play in safety.
A year after the collapse, another tower to the south took over TV transmission duties, and Hemmingford instead became home to this shorter cell phone tower, a monument to the tragic event that took place in 2002.
I know Hemmingford has a big heart, always has. You always respect the people that has tragedy hit them.